Welcome back. We're on 3.3, page 2, and we are to use the change of base formula and a graphing calculator to graph the function. So this is what we would have had to do years ago, but we have better technology than that. But we would have gone, perhaps this is ln x plus 2 on ln 1/3. That's our change of base formula that we had just looked at on the previous page. Where was that one at? Anyway, we'll go back to this page right here. So that's our change of base formula, and you can do that with plain old logs. So if I go ln x plus 2, that's extraneous parentheses there, but I'll live with them, divided by ln 1 divided by 3, and I'm going to zoom 6 this, and we get this, and our calculator kind of lying to us here. In fact, we can look at this and we realize negative 2 is an interesting value because we can't quite put negative 2 in. This is actually an asymptote. This goes up forever and ever. If I go second calc value negative 1.9999, I actually get a value up there on the graph. It's just our calculator just stops, but it goes up forever. If I go negative 1.999999, we're up at 14.67. So it's just running down that. It's just running up to infinity eventually. So we need to recognize and not just trust our calculator. We need to recognize we have an asymptote at negative 2. And we're just supposed to be doing this on our calculator, so it looks like it goes through 0, negative 1, approaches here. Looks like it's something like this, and I'm okay at that point. It might go down a little bit quicker than that, but I'm okay with that because this is to be done on graphing calculator. Now, it's definitely worth showing. We could have just done this. Alpha window, clear that. Alpha window log base 1 divided by 3 of x plus 2. And there's our second function. I don't know if hopefully you can see that the red just went right over the blue. If you can't see that, the color didn't show up, I'm going to just turn this graph off for a second and graph just that second function. You're going to see, hey, we've got the same function. Okay, so I don't care how you do these. In fact, we could do this with change of base, but go ahead and just get a sketch of the graph for me somehow. If you want to just graph this exactly as it is here using log base, it's probably, to be perfectly honest, don't consider it you're cheating the system here. It's probably a better way to do it with the technology we have access to. So I'm going to go alpha window log base 3 square root x, and before I enter that, it's definitely worth taking a moment and just saying, hey, what is our interesting value of x? X cannot be 0. In fact, x most definitely can't be negative for a couple reasons. Logarithms, we can't have negative arguments. And we can't have square roots of negative, but x can't be 0, so everything should be to the right of 0, and we ought to have an asymptote at 0. Let's take a look. So I don't believe this thing just dies here. I think if I put second calc value 0.000001, the graph continues down here, even though it looks like it stops. So we have an asymptote right here, and it looks something, boy, it doesn't get big in a hurry. It looks like it goes through 0, 1. It looks something like that, but let's go ahead and take it right down to the bottom of that graph. Now, I'm really not probably completely accurate on the height of it over here. That's okay, we're using calculator on it. Okay, use the properties of logarithms to rewrite and simplify. If I'm base 9, I want powers of 9 out of 243. So I'm going to look at 243 and I'm going to see, well, I hope 9 divides it. Let's second quit. If not, maybe 3 does, because that's a power of 9. It's 9 to the 1/2. But let's go 243 divided by 9, and I get 27, and that's 9 times 3. So watch this one. What if I treat this like log base 9 of 9 squared times 3? That can split into log base 9 of 9 squared, right? 9 squared plus log base 3 of 9. And this is a good non-calculator problem, like on a quiz test where you can't use your calculator. This is the exponent that turns 9 into 9 to the second. Well, what's the exponent that would turn 9 into 9 to the 2? This whole thing is just 2. Here's another way of looking at it. Property 3 over here would allow me to pull that exponent out in front, and I would get 2 times log 9, 9. What's the exponent that turns 9 into 9, 1? 2 times 1. So this is just 2. This should be I've got this wrong. 9 and 3. What's the exponent that turns 9 into 3? Well, this is really 9 to the 1/2 power, square root of 9. So what's the exponent that turns 9 into 9 to the 1/2? 1/2. So I get plus 1/2. I get 2.5 or 5/2. Now they might not all work out that nicely. Property 1 lets me write this as log base 3 of 9 to the second plus log base 3 of 2 to the fourth. I'm going to pull that 2 out in front. You could make this 81, but I'm going to make this 2 times log base 3 of 9 plus, I don't see anything really good happening with this one. I think I'll pull that 4 out in front. 4 times log base 3 of 2. Let's see, this is 2 times, the exponent that turns 3 into 9 is 2. Plus 4 times, the exponent that turns 3 into 2, I don't know. So 4 times log base 3 of 2. So we end up with 4 plus 4 log base 3 of 2. Okay. ln 8 plus ln e to the third. What's the exponent that turns e into 8? I don't know. E's an irrational number. That's a rough one for me. What's the exponent, however, that turns e into e to the third? This is 3. Now you could pull the 3 out in front and have 3 times ln, or log base e of e, log base e of e 1 times 3, but this is 3. So I just end up with 3 plus ln 8, or vice versa. Okay. Quotient, there's our first quotient on this section. Quotient, if I've got a quotient as an argument in a logarithm, I can separate those into subtraction. So this is ln e to the 5th minus ln 7. What's the exponent that turns e into 7? Who knows? What's the exponent that turns e into e to the 5th? 5. Okay. And then here we are to use the properties of logarithms to verify the equation. I've got a choice here on 46. I can try to break 24 into 2's and 3's, and I think I can do that. Or I can use these rules in reverse and smash things together. So I'm going to work on this side. I love this negative here. I'm just going to let it hang out till the end. This becomes, I can bring this 3 in as an exponent. It's just using this rule backwards, bring that n in as an exponent. And I get ln 2 to the third plus ln 3, that's negative ln 8 plus ln 3. And now if I use rule 1 backwards, take this sum of logarithms, log of a product. This becomes negative single logarithm of 8 times 3, 24. And we've got it. Again, you want to do this differently. You want to break 24 into 2's and 3's and work on the left side. Be my guest. Let me know what I can help you with, and we'll see you soon.